This will be part 2 of Gaussian elimination. Imagine we have this matrix, augmented matrix, right? And we trying to find the solution to this matrix. As always, we have 3 equations here, just like in the basic elimination that I did earlier on. We have equations, but here we have more than one variable. We had x and y, but now we have z, and then we had 2 equations, but now we have 3. So, but the same ideas are the same ideas, they apply, right? Notice, do you like writing down the steps? So what you're gonna do, the first thing, you try and find, you can move these equations around, you know. The fact that this equation is here, it doesn't mean that it's wrong moving into number 3. It's just that someone decided to put these equations like this. Someone else could have put them in a different way, but it doesn't necessarily change anything about the equations whatsoever. It's just someone decided to put them. In this case, they put them in such a way that we would like them to be put in. We would like the first row, the first number of the first row, right, to have a number of 1. That makes our work a whole lot easier. And then there are no fractions, we're good to go. So what we are trying to do here, we are trying to eliminate this x and then this x, almost similar to what we did, but now we don't remove the first equation like we did, but it's the same ideas. We're using these equations to eliminate this and eliminate this. So what we're gonna do, what we did here, in order to make this the same, we need to multiply by 2 or minus 2. I'm just gonna use minus 2. So it's gonna be minus, we have rows here, not equations. So it's minus row 1 plus row 2. And then that answer, remember we had an answer, we drew a line and we had an answer. That answer will replace this one, row 2. The same thing, imagine this one doesn't exist now. We're gonna, oh sorry, it's supposed to be minus 2 here. It's supposed to be minus 2 here. Minus 2, the whole row. Then this side, we're trying to get rid of this one. It's going to be minus 3, row 1, plus row 3. And then that will give us row 3, right? If you were to multiply the first, this one, if you were to do this step and multiply by 2 first, and then after multiplying by 2, like we did the previous, after multiplying by 2, start subtracting. And then once we're done with that, we come to the 3rd row, we do the same thing. It's gonna make a whole lot of mess. You're gonna have so many equations that confuse you. So you do this thing quickly in your head, like, you know, I'm multiplying this by minus 2, and I'm multiplying this again by minus 3. You do everything in one step, because the less steps you have, the less confusion. This one is the equation that we're using, the one that has 1. We don't touch it. It's good to go. We used it. We can even indicate. So -2, we start with -2. -2 times 2, this one, the numbers below here must always be 0. Must always be 0. And then -2, if you don't get 0 here, something is wrong with your multiplication. And minus 2 times minus 2 times 3 is minus 6, plus 3 is minus 3. And then if we do the same thing, minus 6 minus 2 will give us sorry, minus 2 minus 3 will give us 6. 6 plus minus 2 will give us 4. And then the same thing, minus 2 minus 2, 4, it's minus 8. And then plus 4 is minus 4. Right? And then you do the same thing here. You're going to get 0. And then you're going to get minus 15. You're going to get 10. You're going to get minus 15. Right? Then now, just imagine the first one doesn't exist anymore. We are done using it. Just imagine now we are left with this equation 1 and 2. Just imagine we're left with this one. Right? You see, it has, because it's 0, it means there's nothing. It has y and z. It means it has 2. Just focus on these ones. These ones here. In this box. It has 2 variables. It's the same ideas. It's even more of the same ideas as the one we did. In this case now, we have, you want to make these 2 numbers the same, right? What can you do? Well, the easiest thing you start with is trying to make this thing 1, or at least the smaller number. You try to make it 1 and see if you don't get a fraction. In this case, we get a fraction. Not a good idea. Then another thing, we could multiply this by 15, and then multiply this by 3. But there's an easier way. You can just multiply the first row by what? By let's just say by 5. Yeah, let's just make it -5 to make it easier. And then we add it. It's gonna cancel this. It's gonna make this thing 0, because we're trying to get this thing 0. This one we are sorted. We are trying to use this equation now, this one, to make this one 0. So what we're gonna do, we're gonna say, let's say minus, just be consistent, minus 5 times row 2 plus row 3 will give us row 3. That's just right there. Matrix here. This one doesn't change. We've used it, so it stays like that. Then 0. This one, the one we're using, we write it as it is. Write it as it is, and then now we do this whole thing, and the answer we get here, we write it here. This 0 will never change. 0. And then now we come here, we want to write the answer. Minus 5 times 3, minus 3 is 15, plus minus 15 is what? 0, which is what we wanted. If you don't get 0 here, something is wrong. We say minus 5 times 4, it's minus 20, plus 10, minus 10. Then minus 5 times minus 4 is plus 20, plus minus 15 is 45, right? And then we are almost done. We are almost done. We're almost done. The aim of this thing is to try and get something like this, where you have zeros. Can I change the color of the pen here? Yeah, you can. Something like this. It's always the aim to get something like this. That's the aim of Gaussian elimination. To get something, once we have something like this, and then something like this, ideally here you should be having all ones, but you can always get ones by just dividing. Like here you can divide by -3 and you get 1. Here you can divide by -10 and you get 1. But we try avoiding that until when we're trying to solve for the answer. In this case, when we solve for the answer, we can say now, because we are done getting the zeros, we can say -10, start with the bottom one, which is z is equal to 5. This implies that z is equal to -1/2. Then move on to the next one, the previous one. The next one is with the -3 y plus 4z is equal to -4. And then we replace, because we have z -3y plus 4 -1/2 is equal to -4. Then we solve everything, we should get your y. Your y should be 2/3. Then you come to the third one, which is x plus 3y minus 3z is equal to 4. Then your x, after replacing, y is 2/3 plus 3, your z is -1/2 is equal to 4. This will equate to a value of half. And you're good to go. Now, let me do another example. I'll do it on the next video. Just trying to make this video short.